Ladies and gentlemen, thank you for attending Ticon webinar. Today, we'll talk about optimal site selection and retail analytics in a data-rich environment. Recently, Gregory Brodski, Ticon CEO, spoke on this matter at the Enterprise Location Intelligence Summit in Quebec. His presentation was well attended and met with great interest by data analysts and GIS specialists. That is why we decided to repeat it for retail and real estate professionals. The presentation is in two parts. Part 1 is dedicated to new concepts of analysis and Part 2 to data quality. Dr. Brodski will be personally answering the questions after each part. The current landscape of data collection and availability offers more opportunities for retail analytics than the industry typically leverages today. For Ticon, new advancements in AI and big data bring both opportunities and challenges. Beyond refining our algorithms and acquiring new data, we must also demonstrate the value of these tools to industry professionals. There are a number of applications in the field, from regional analysis to trade areas delineation, and all of them can benefit from comprehensive data analytics. In this presentation, I'll focus on just 3 key challenges we address more effectively in this new data-rich environment. The use of new information on the top of traditional one allows not only to obtain refined estimation and forecasts, but also to control a wider spectrum of important business aspects. And artificial intelligence isn't just speeding up traditional processes, it can fundamentally reshape how site selection decisions are made. I would like to demonstrate this on a revenue forecast example, since this task is common for most applications. Even the latter use case requires revenue potential prediction to compare projections with actual performance over time. To enhance accuracy in revenue forecast, we introduced several new concepts, and each of them is based on a specific type of enriched data. Consider this. In many retail industries, a 20% difference in revenue can determine whether a site is profitable or not, since profit margins often range from 5 to 10%. Let's see how the use of novel concepts helps improve prediction accuracy and underpin optimal decision-making. In this presentation, we'll address highlighted concepts, and the first of them is advanced estimation of visitor rate, also known as traffic catch. Current site selection practices use annual average daily traffic as a primary parameter for estimating customer numbers in traffic-dependent businesses. However, roads with similar AAT can produce different visitor counts, even for the same retail brand. This fact is illustrated by the lower graph, summarizing the data gathered from 88 convenience stores. The study revealed that the variation in VR stems mostly from the influence of surrounding road networks, which is especially important for freshly opened business sites. By describing adjacent road network as a connected graph and using AI-powered trajectory analysis, it is possible to assess the contribution of all influencing roads, nearly doubling the accuracy of visitor rate predictions. Improving revenue forecasts further involves assessment of traffic flow fluctuations for each road that have been assigned as relevant for a particular location by road graph analysis. Traffic pattern fluctuations vary substantially from place to place, yet each site tends to have consistent fluctuations over time. It's also proven that both the likelihood of purchases and the average spending experience temporal variations. Look at the left graph, where the peak period is highlighted. Based on this graph that built for convenience stores, site number 1 with stronger afternoon traffic outperforms site number 2. While having 10% lower AAT, it generates 10% more visitors. With accounting for seasonal and weekly changes, traffic fluctuation analysis enhances revenue estimates by up to 30%. Another critical factor in revenue forecasting is the average transaction value, which depends heavily on buyers' demographics. Traditionally, this relies on trade area demographics, typically of 5 miles around the site. But the fact that a person lives in store vicinity doesn't mean he or she will ever pass by a store door. In contrast, knowing demographics of people in passing vehicles, you can directly access the purchasing power of potential customers. That is why we are introducing a concept of traffic flow demographics that observe exact road segment, combining highly detailed demographic data with vehicle origins, again using the trajectory analysis. Traffic flow demographic profile includes age, gender, income, ethnic, and education distributions attributed to exact road segment. In many cases, good outcome here requires more granular data that are available on census blocks level. Good news is that highly granular demographic data, up to 1 mile granularity, is now available from MapAI. The left graph shows, on the example of customers' income distribution, how significant the difference between traffic-based and local-based metrics is. With the use of concepts described, site selection follows 2 steps. The first step identifies a number of potential locations in the region considered. Then, based on listed criteria, ranking score will be automatically built. Of course, a detailed report will explain the outcome, though you can compare the potential of pre-selected sites at a glance by their color gradient. Obviously, these advancements in business intelligence can be implemented only conditionally to a precise data availability. Such data must offer full coverage in order not to limit aerial search, but at the same time high resolution to distinguish any specific location, offer completeness to deliver everything needed for the analysis and accuracy. Moreover, for feasibility studies, error control should be available. Unfortunately, no single source of data meets listed requirements so far. Consider the 2 most common categories. DOT counters cover nearly all U.S. roads, but traffic changes along these roads are very pronounced. In fact, counters data covers less than 5% of road segments that should be distinguished from location intelligence standpoint. Mobile data tracks over 70% of cell phones, yet most provide only a few data points a day, missing 95% of driver movements. And for many other sources, similar diagnoses can be made. That is why the attempts to build sufficient business intelligence on just a couple types of data have little hope of success. Still, all data sources will remain valuable and usable if applied with the consideration of their physical properties and combined with the help of multi-factor analysis. We achieve the required accuracy through multi-source data use and continuously update the list. By the way, the name of our company, Ticon, stands for Traffic Information Consolidation. We align diverse types of data in a unified virtual space with the adjustment for each source's resolution, spatial, and temporal coverage. For example, traffic monitoring performed by state-of-the-art detectors offers the highest resolution. Cameras or LiDARs detect vehicles at exact road spot with the 95+% of accuracy. Of course, traffic monitoring is expensive, therefore having little road coverage spatial-wise. DOT portable counters are much cheaper and used more often, so road coverage is much broader. They are still of good resolution, but provide only a couple days of measurements and not every year, meaning that temporal coverage is small. Low resolution of mobile data stems from rarely transmitted signals, but it obviously demonstrates widest temporal and spatial coverage. The algorithmic secret here is in joint processing of the diverse data related to one geospatial point with the adjustment for the properties, physical origination, and accuracy of each data type. As a first step, AI-driven multi-factor analysis filters, cross-verifies, and standardizes the data, creating a reliable pool tied to specific locations and times. This is the foundation of the accuracy in our business analytics. And that is why, when we are asked, who else provides the same data, we can honestly answer, no one. It only exists once we produce it, much like manufacturing a product from raw materials. A simple example of application of multi-factor analysis to input data is verifying DOT counts. Again, filtration is needed not because DOT data is bad. These values may be absolutely adequate for road maintenance, but not necessarily sufficient for location intelligence. In Massachusetts, I took a liberty to use my home state for this example. From 14,000 counters, we filtered out over 1,000 through multi-factor automated testing. As you can see on the left, verification by each parameter did filter out some counters, and at the end, total number of discarded counters came to 1257. This eliminating misleading data from computing significantly reduces ADT estimation errors. We must admit that in this example, the quality of counting is very good. Only 7% were filtered out. For other data categories, the filtering rate can be more pronounced, sometimes up to 90%. Further processing of verified data continues with 3 types of algorithms. Road graph analysis treats the network as a connected graph where proper segmentation is vital. The segmentation should account for continuous and interrupted traffic flows and keep the segments long enough for accurate speed/density analysis, short enough for sufficient resolution, and optimally configured to support mobile data processing. Dynamic speed/density analysis, which applies various deterministic and statistical models depending on types of road segments and speed-changing aspects. This multi-model approach had proven significant increase of accuracy, allowing for probe data validation and independent volume estimation. The latter achievement is critical, especially for the areas with the lack or absence of counters information. Saturation analysis adds geospatial and regional details to support accurate volume estimation and driver behavior assessments, as well as error control. Together, these algorithms deliver the complete set of parameters needed for business analytics. Fundamentally, through AI and advanced engineering, we transform vast pile of data into actionable information for location intelligence. Frankly, I wasn't sure the slide is needed, but I like the picture. Of course, this approach requires significant investment in multi-source data and computing power, but the result is exceptional accuracy that makes site selection optimal indeed. For traffic volume, we offer a maximum error of 20%, with an average of 11%, and with 90% confidence. On the color scale, we marked zones of good, tolerable, and insufficient data accuracy from retail location intelligence point. Unmatched precision of Ticon data enables us to distinguish even between sites with just a 20% difference in projected revenue. Often, this small difference determines success or failure of clients' businesses. Ongoing field tests, like demonstrated by surrounding graphs, ensure that we maintain and improve the accuracy of our algorithms. The format of this presentation does not allow me to illustrate our demographic and road control data journey. I will just share the results. Our demographic data is provided with a resolution of 3 square mile cells across the U.S. Our road graph perceives segments with 10% traffic variation. On data delivery, since 2016, we've provided on-demand site selection reports and bankable feasibility studies. Our website offers a straightforward ordering process with reports ready in 3 to 5 business days. For broader planning, our demographic and traffic data platforms support regional analysis, expansion strategies, or integration into your systems. Please contact us to order a demo. To conclude, combining multi-source data with engineering algorithms and AI advancements creates a robust foundation for comprehensive business analytics, driving successful site selection, optimized performance, and improved returns in retail. Our unique virtual detector technology, proven in the US, is ready for global expansion, and I hope this year will mark the start of that journey. With that said, I welcome your questions.